Dear friends, I'm very happy to take the second session on VLSI design. Last session we discussed about the introduction to VLSI and what are the software languages used in the VLSI design. Today we will discuss what is the importance of VLSI. So the importance of VLSI basically depends on the functionality, productivity and how it is used. So the functionality is, as I already told you, so whenever we develop a chip, we fabricate a chip, at the final stage, after fabrication only we will check whether it will function properly or not. But using VLSI, before fabrication, we can check the functionality. So this will help us, the time, the cost and everything. So because of this, biggest advantage, we go for VLSI. And productivity, since it has excellent applications for real-time applications, all industries use VLSI, both in terms of Verilog HDL, in terms of VHDL. All industries now go for this VLSI design. And one more application is how it is used. So normally the usage is depending on the documentation. So the documentation is based on how it is documented. So normally if I design an electronic device, for example a television, it can be documented for years. It will be useful for years. But the upgradation cannot be done for that device. Whereas if I design the same concept using VLSI for that special application like television, now the technology has improved. Now I can use quarter point focus, etc. So this is the way the usability is also done by using VLSI. So in a normal device without using VLSI, I can store it for more than 5 to 6 years. But after that, it cannot be improved. But whereas a VLSI device can be improved at any time. Then example is, as I told you, the quarter point focus is available now. So and it can be also stored for years. And if I use a C program, and one more example I want to tell you. If I use a C program, I develop a device, and if I store it for years, it cannot be used because the next day some other code will be there. But whereas a VLSI can be documented for years, and that application will be stand for everywhere and any time. So that is why we go for VLSI. And there are two methodologies used in VLSI. One is top-down design methodology and bottom-up design methodology. So in VLSI, we use top-down design methodology. So how this top-down design methodology is used? Suppose I take an application, say FFT, fast Fourier transform. So the fast Fourier transform will be broken into n can be broken or decimated into a 2n by 2 point, and these 2n by 2 point can be broken or decimated into 4n by 4 point transforms and 8n by 8 point transforms and so on. So this is the way a top-down design methodology is useful for any VLSI design application. So you have a main module. The main module will be subdivided into sub-modules, and the sub-modules will be again divided into unit cells and so on. This is the way methodology, that is top-down design methodology, is used for VLSI application. And because of this top-down design methodology, VLSI is very famous. One more example I want to tell you is microprocessor. Suppose I want to design an 8085 microprocessor. First I should know how this 8085 microprocessor works. That is the main module. So the main module is subdivided into so many other sub-modules. So inside the microprocessor you have memory, you have accumulators, you have input device, output device, etc. And this inside this you have so many other unit cells. Likewise, you can break the top-down design methodology main module into sub-modules and so on. So this is how in VLSI the top-down design methodology is used. Then there are, as I already told you, there are two types of language. One is Verilog HDL and another one is VHDL. So Verilog HDL, it is widely used for applications, real-time applications, because it is very similar to a C language. And VHDL, it is nothing but very high-speed integrated circuit hardware description language. It is an abstract language. So it is a strongly coupled language, whereas Verilog HDL is a loosely typed language. So that is why Verilog HDL is widely used in more industries, because it is loosely typed language. So you can use, suppose if I use an vector, it cannot be used the same model for a VHDL. So some conversion has to be done for vector applications, but that is not the fact for Verilog HDL. Directly you can use this vector for any type of applications. So this is the way it is widely used compared to VHDL. Verilog HDL is a loosely typed language and it can be used for any type of applications. So now today we discussed about how and what is the importance of VHDL, Verilog HDL, VLSI design, and how it is documented, how it is functionality, how it is done, and how it is productivity, how it is used, and how and where it is used by using methodologies top down and bottom up. And in VLSI we use top down design methodologies, and we plan a different design flow. So the design flow will be explained in the next part. And thank you, and if you have any queries you can call me. My number is 9344707218. Thank you.